Hello, everybody. My name is Lior Frenkel. I'm the CEO and co-founder of Waterfall Security Solutions. We are an Israeli-based cybersecurity vendor, and our basic technology is called the Unidirectional Security Gateway, and our target market is the critical infrastructures and utilities, mainly here in the States and in Canada. Just to go back to the last sentence of Stephen there, a bit of paranoia is good, and we in Israel, we eat paranoia for breakfast. So we take security very seriously. And the difference that you have here between regulations and security is the distance in where we come from is a bit smaller than here. We don't have regulations and security. We have them much more closely combined. Saying that, again, you can always comply to regulations and be insecure, and you can be, let's say, as secure as possible, but don't comply to the regulations. Okay, there usually is an overlap, and the best way to do is to try to make this overlap as big as possible. The hour is late, and I'll do it in a fast-forward mode, and I'm not the last speaker, so saying that, stop me and ask questions as we go, because I will not. I don't think that we'll have time at the end for questions. This is a generic topography of a utility of a critical infrastructure with the critical network, the SCADA network, industrial network, a business network, and the internet, where usually the critical network with the CCAs is connected to the business network for various business needs, mainly to update the business network with what's going on inside, but in some cases also to receive information from outside or to get commands. Business networks are connected to the internet, and this whole situation is very risky, as threats and attacks originated from the internet can hit your critical network through the business networks through these connections. And even we don't even need to go to attack or nation state attacks and so on, even just plain viruses or unintentional activities. Network threats or the interconnectivity threats, some of them are routine, malware propagation through the connection, even if the connection is secure. Okay, it's encrypted, it's a VPN, but through that connection everything can pass. Okay. A VPN does not make a connection secure. It just makes someone from the outside not being able to understand what's going on within the link. It does not make it secure. And as we said, through the VPN, people discussed before me about open ports and how to manage the firewalls and what happens and so on. That's sure. And more advanced threats today are the zero-day attacks of firewalls and targeted attacks on specific industrial applications or even specific industrial facilities themselves. Okay, and as the Stuxnet that everybody is aware of today, and okay. Another thing which is important to understand that happens when you have these connections let's assume that your critical network is infected with a malware. Modern malware today connects to an external command center to be activated, to signal the owners, hey, I have infected the target, waiting for your command, and so on. And this communication outside can be done naively, okay, and can be done in a very complex way, in mimicking allowed communication, allowed protocols to circumvent content filters and firewalls. It can ride within allowed protocols, and from there out to get to the target control center. Again, the StackNet attack used peer-to-peer communication between different network nodes to send information out, and it is a known fact that existing network security gateways that should have alerted of that communication failed to notice the StackNet outgoing communication. So it's not it's not a science fiction. This is how things work. And again, StackNet is just a specific example that got the headlines of the news. It's not the first successful attack, and it's not the most. It's not even the most technically complex one. It's just a sexy story for the news. But for us, it's good. It brings business. To protect against these routine and, of course, the advanced threats, advanced perimeter protection technologies should be introduced and should be deployed. And the one that I'm talking about is, of course, also the one that we are developing and manufacturing, which is unidirectional communication or unidirectional security gateways. The best way to not be in risk of online attacks is be air-gapped, okay? Be disconnected from any external source. You cannot be online. You have no online risks, okay? If your critical asset is physically inaccessible from any external source, no external source can hack in. That's simple. Saying that, just a second. Saying that, your business needs require you to get information from your industrial networks. So you can technically be air-gapped, and the industrial networks knows how to operate without any external communication, okay, but by design. This is how they work. Most of them. It's for safety and operational needs. They don't need external communication to operate correctly. But the business need says, hey, I need to know today what's going on. I need real-time data from the industrial network. I want to know the production rate. I need ERP data. I need alerts. I want everything out. A unidirectional security gateway retain both of these needs. If it is a real hardware-based unidirectional system, as it should be, it allows data to flow out and prevents in a physical way any data or any communication to come in. So what you get is you get the security level of being air-gapped with the business requirements fulfilled. You can update the external, the business network and headquarters and whatever in all the information and all the real-time data that you need. Saying that, one thing that needs to be a technical issue that needs to be fulfilled to doing that is protocols, communication protocols and application work in a bidirectional manner. The simplest protocol that you can think about that is used requires some sort of acknowledgement. Hey, the data was received, everything is okay, you know, the destination network application is available to receive data. Everything goes bidirectional. So one thing that a unidirectional security gateway needs to provide is an emulation or mimicking of a normal two-way protocol behavior on both sides, on the industrial network, in the SCADA network, and in the business network. So the applications sending and receiving the information will feel as if the other side is accessible and answer them all the required answers. Or else they won't work. That's a preliminary requirement. I'll pass this fast. This is a under the hood picture of a diagram of how complex a real-life unidirectional security gateway is built in a very multi-layered architecture that provides, that is designed for two main things. One is reliability, manageability, and efficiency. This is mainly the hardware that is used and at the lower level of the product that's in the middle. And externally, there should be a easy enough way to add support for additional applications and protocols and third-party applications. To provide a product which is industrial grade, that an operational installation can rely on to be the sole outgoing communication channel from a power plant, a nuclear power plant, a substation. You need a reliable system, an efficient one, and one that you can manage in a way that if anything goes wrong, you know that there's a problem and you can try to troubleshoot. Or else this technology will not be relevant to these types of installations. Today, unidirectional security gateway is a mature technology. This is not a sales pitch, so I'll just say in general, our technology was, and other technologies were developed since more than 10 years. We have hundreds of installations, mainly in Israel and the United States, all in operational and mission critical environments. Specifically here in the States, we have a lot of installations in nuclear power plants. I think that over the majority of the nuclear power plants in the United States are our users. And we have also fossil and normal power plants, water facilities, oil and gas installations. But back in Israel, 100% of the critical infrastructure utilities are waterfall users. All of the types, okay? We have refineries, we have the power plant in Israel, transmission and chemical facilities, trains and rails and airports. Everything is protected. All the data streams from the applications inside, from the industrial application to the business network, and all of the critical networks are physically inaccessible from any outside source. shoot.
So I do ever run into a situation where I understand the security implications that come with bidirectional communication, but I completely understand that by using this as a means to sort of view the information without being able to send anything back down the line, that actually works quite well in protecting critical
Yeah.
infrastructure. But do you ever run into situations where people say, we just need to be able to get information back there, and is there any way you can get around that? And how do you answer that question if you do?
Okay, there are, let's say, 3 types of topologies in the world. Okay, one is, as I described, you have your critical network, and you do not need to access it for its operational mode from remote. And in this case, we provide an optimal solution. Okay, and security-wise, you never get 100% security and 100% functionality. It's always a trade-off. In this topology, there's no trade-off. Okay, you get full security. Nothing can hack from outside. Never. Okay, it's physical security. The product itself is fiber optic unidirectional. One side can send outside, has only a laser LED sending to the external device, which has only a photocell. Okay, nothing can go back. But the only business need you have, the only operational need you have is to send data out. So you retain the full business functionality with 0 risk. Okay, very good as security goes. Now, there is the other extent saying, hey, I have two networks, but I must have a interactive communication, not bidirectional, okay, interactive. It's always going back and forth. I ask a question, they give me answer, and from the answer I give another. We don't sell there. Okay, they have a, no, of course, you know, if that's their business, you know, they need to understand the risk, as said in what's NERC CIP, and they need to deploy whatever possible security they have, and they will always have some % of risk. You cannot, you know, fix that.
So your
Now,
product is really designed for those really high-risk systems where you just absolutely positively need the air gap and just read that information.
well, it's the other way around. We are fit for all the places that just need to update. Even if it's not that critical, if you can secure it like that, it's just logical to do that. No, you don't have any risk afterwards. Why take a risk? Now, there are places in the middle saying, hey, I don't need nothing from outside, but occasionally, once every couple of months, I need the vendor of my turbine to do some remote maintenance. What do I do then? Okay? So in these cases, they deploy our technology going out, and by the way, usually also updating the vendor of what's going on with the equipment, okay? You know, the usage logs and all the data that vendors like to have in their remote, central remote maintenance center. And then when there is a plan for a planned maintenance activity or a failure, they open physically, someone from inside the network opens or physically connects the 2 networks, allows them to get in for a specific time, and then shuts it down. But by the way, we have another product that does this automatically, well, not automatically, but that automates this procedure, just so people won't forget the networks to be connected, okay? But again, it's just to connect the networks. And then what you get is that instead of being 99% secure all the time, as with firewalls, you are 100% secure 99% of the time. Okay, and it's much better. Okay, you are insecure only in the 2 days a year that you need the remote access. But all the rest of the time, you are fully secure. So we sell to these two types of customers, and the third one lives with firewalls and a lot of insurance. One very common application for us is in the generation area, power generation. You have your power plant with your plant historian and other applications, and waterfall systems are deployed to replicate the plant historian. We have here Brian Owen from OSIsoft. We are partners, Waterfall and OSIsoft are partners for many years now, and we have a very large number of installations of Waterfall replicating PI historians. And we replicate in real time the historian server to a replica server residing in the business network. And the business users access the replica server. They don't access the operational historian in the plant anymore because they cannot access it anymore. They have a replica one, which is replicated in real time, okay? And from there on, the critical network is secure, and the business processes continue as they did. Okay, we have these types of installation in numerous amount of power plants here and in Israel, and we have also installation in Europe and Asia, but as I said, here mainly here. This I just said. We have also support for many other industrial protocols, specifically DNP3, which is relevant more for transmission applications, and we transfer DNP3 protocol outgoing from sources to the EMS network. And again, this is just two examples. There are a lot of other types of installations and usages.
So,
yes.
Are they appliances?
Yes. Yes. Our product is two appliances. One is the sending side, one is the receiving side. The sending is connected into your or onto your critical network. And the receiving side, usually in the same room, okay, but it's connected to the external network, to the internet. And the software agent that we have on each side connects with the source application, the DNP3 device, or the PI historian, or the OPC client, and pass the information to the external side, to the external destination. And the security is provided by the hardware, okay, the optical, the unidirectional optical layer, and the functionality and the connectivity is provided by the software agents.
So this diagram, so is it the fact that you are trying to deploy sets like this diagram?
Yeah. If you want to buy just one, we'll give you free. Yeah. Well, yeah. We technically can support I think 1.5 miles by the standard of the physical of the optical transmitter that we use. But in real life, when you have a channel, to make it unidirectional, you just need one cut, one segment to be unidirectional. You don't need all the physical channel. And because you want to retain control of the gateway in your critical network, so usually both sides are connected within the critical facility. Okay, and as I said, most of the time in the same room you have your industrial network rack, and you have your business network rack, and we are connected between the racks. Both sides. On the substation, exactly. Okay, I have 2 more slides. I did it very fast. Let's go back to NERC CIP as an overview. But we have, by the way, detailed white papers on the mapping of our technology to NERC CIP and to the draft NERC CIP 4, and whom of you who is relevant also for the NRC nuclear regulations. And if anybody wants, I'll be happy to provide them. But in a high overview, CIP 3 talks about security management, and one thing that you gain that when your critical network is inaccessible is that you can retain data within, and if you don't send it out, it's secure. Okay, no one can come from outside and steal the information that you don't send outside. That's one nice benefit. I think that the benefits about the electronic security perimeters are clear. Okay, and then you cannot mess up with our technology. Okay, no one can open a port and now it's bidirectional. Okay, it's physically impossible. So there's no misconfiguration, there's no misuse, there's no nothing. It works, or the worst thing that can happen is that it will stop working, but nothing can open it to be bidirectional. So you're always secure. And CIP 7 about system management. When you get into documenting your security products for NERC CIP, the documentation required to support our type of installations is dramatically reduced. Okay, there's no security configuration, there is no options on how to do it, and this is very helpful, you know, in the ongoing maintenance of NERC CIP. And systematic benefits that you get, which are not specific to a specific NERC requirement. As I said at the beginning, it's always good to be compliant and more secure. So in this case, you are compliant. Okay, no one can question the level of security that installing our system provides. So you are compliant with any security regulation that is in NERC, or I can presume will be. And you are also secure. So you benefit from both of that. And as I said, reduced documentation, it is an overall benefit. And also the audits and the assessments are reduced because there is just less to check. Okay, there is no rule set, there's no patches on the software and to see who has remote access to the system. It's a physical unidirectional gateway, and there's much less to check to see that it works. Any question? Or additional questions? How much time did I take? Thank you.